Hello again. This video on section 2.6 will be about solving absolute value inequalities. As you recall from earlier, absolute value is the distance between the graph of a number and its origin. Okay, so distance is always going to be positive whether you go distance to the left or distance to the right. And keep in mind that the origin will not always be 0. Okay, so process for solving absolute value inequalities. First thing you want to do, strip everything away from the absolute value bars. Okay, so there should be nothing kind of hanging on to the absolute value bars. Okay, complete any addition, subtraction, multiplication, and division to clear everything away. So all you have is some absolute value, 2x minus 5 is less than or equal to 10. Okay, something like that. If it doesn't look like that, you're not ready to solve absolute value. Okay, so if you have something like 2 minus x times the absolute value of 2x minus 5 is less than or equal to 10, well, then you need to do some algebraic manipulation to get rid of this 2 minus x. Okay, so that's what I mean when I talk about stripping first. Clear everything away from the absolute value bars. Okay, and we'll do some sample problems like that, so hang on tight. 2. Determine if you're working with a conjunction or an AND problem, as we saw in the last section, AND, or a disjunction, OR. So you got to determine if it's an AND or an OR problem, and it's not going to say AND or OR. Okay, so if you have absolute value bars less than a number, like I did in this sample problem here, less than or equal to, that is an AND problem. So if you've got distance is less than, think less than, it's an AND problem. If the absolute value is greater than, okay, the distance, the absolute value is greater than or equal to, okay, some number greater than, okay, I misspelled greater for a reason, okay, it's an OR problem. So greater than or equal to is OR, less than or equal to is AND. Okay? Then, 3, drop the absolute value bars and rewrite the equation. Okay? So, at my 2x minus 5 is less than or equal to 10. Now, this was less than, so then step 4 says put AND or OR in. So we write in our AND. Then step 5 says drop the absolute value bars again and rewrite the equation, or in this case the inequality, but flip the direction of the inequality. So here I mistakenly started to write less than or equal to. We're going to flip the direction of the inequality. So now it's greater than or equal to, and then take the opposite of whatever's on the right-hand side. So this was a positive 10, so it's going to become a negative 10. Okay? So essentially, all absolute value questions are 2 homework problems in one. Okay, you're going to drop the absolute value bars, keep everything the same. You're going to write AND or OR. You're going to drop the absolute value bars, change the direction of the inequality, and then change the sign. And then you go ahead and you solve your 2 homework problems. Okay? So once you solve your 2 homework problems, then you'll graph the solutions on the same number line, like we did in the previous section, and then you'll write your algebraic solution. So let's take a look at some samples. The first one, x plus 4 is less than 10, or the absolute value of x plus 4. So first thing we do is strip everything away from the absolute value bars. That's done. So it's less than, so we know that this is an AND problem. Okay? so less than. So we do x plus 4 is less than 10, and x plus 4, drop the absolute value bars again, change the direction of the inequality, and take the opposite of the other side. So now I have my two problems to solve. So we'll solve this one. So I'll subtract 4 from both sides. We're working on the left. So we get x is less than 6. And we'll subtract 4 from both sides. X is greater than negative 14. So we go to our number line. We have critical points at 6 and negative 14. We want all the values that are less than 6. I did that in blue. So my parentheses, those are the values that are less than 6. And x is greater than negative 14. So negative 14 also, and that direction. So the values that are greater than negative 14 and less than 6, that's all those values in between. So that is our final solution. Using our interval notation, our solution is that. And our algebraic solution would be that x is greater than negative 14 and x is less than 6. You can only do this for ands, not for ors. Sample problem 2, the absolute value of negative 2 minus a is greater than or equal to 4. This is a great or, so this is an or problem. Okay? Strip everything away from the absolute value bars. Done deal. That's taken care of it for us. So we drop the absolute value bars. Keep everything the same. Put in our or. That's very important. Rewrite. Negative 2 minus a is greater than, oops, not greater than, because I have to change the direction of the inequality. Less than or equal to 4. Pardon me, negative 4. So, drop the absolute value bars, flip the direction, make everything negative. So now we go ahead and solve. So I will solve the left-hand side. I will add 2 to both sides. I get the opposite of a is greater than or equal to 6. I have to divide by negative 1. So I get a, change the direction, less than or equal to negative 6. It's an or problem, so I'm going to bring down my or to make sure I don't lose track of it. And we'll go ahead and solve the right-hand side. I will add 2 to both sides. I get negative a is less than or equal to positive 2. Divide by negative 1. Change the direction of my inequality, and I get a is greater than or equal to negative 2. I will graph my solution on the number line. Since they're both greater than or equal to, my critical points are negative 6 and negative 2. I'm going to include negative 6. I want values that are less than negative 6. I want values that are greater than negative 2. So values that are less than or equal to negative 6 go to the left. Values that are greater than or equal to negative 2 go to the right. So what satisfies this? Well, x is less than negative 6 or greater than negative 2. Using interval notation, I'm going to have 2 answers. I'm going to go negative infinity and negative 6, or negative 2 to positive infinity. And then you could just write your algebraic solution this way. So there's your 3 different ways to answer that particular question. Finally, we have a problem here where we do have to strip things away in sample problem 3. So let's strip everything away from the absolute value bars. We will subtract 6 from both sides. And we will get the opposite of the absolute value of 2 minus x is less than or equal to negative 2. Then we will go ahead, because we don't have anything stripped away, we still got that negative 1 hanging out in front of the absolute value bars. So I'm going to divide by that negative 1. So if I divide by a negative number, I'm going to have to flip that inequality. So we'll get 2 minus x is greater than or equal to positive 2. My absolute value bars in there. So that's my problem. Now we determine if it's and or. Since it's greater, it's an or problem. So we'll go ahead, drop the absolute value bars, keep everything the same, bring our or over, and drop the absolute value bars, change the direction of the inequality, make everything on the other side negative. Okay? So we'll go ahead and solve both of these. Wow, we got lots of change in the inequality symbol. I'm going to subtract 2 from both sides and get negative x is less than or equal to 0. Divide by negative 1. And we get x is, I think I misspoke earlier. I'm a step ahead of myself. X is greater than or equal to 0. Divide by negative 1. X is less than or equal to 0. Then or, subtract 2 from both sides. The opposite of x is less than or equal to negative 4. Divide by negative 1. Flip the inequality, and we get x is greater than or equal to 4. Graph those two on the number line. So we've got our number line. We've got critical points at 0 and 4. X is greater than or equal to 4. So that is all those points. And it's an or situation. So we want values that are less than or equal to 0. And that's all of those values. It's an or situation. So we want, there's the graph of our solution. That does seem to make sense. So we're going to go from negative infinity to 0 and include 0. Or we're going to go from 4 to positive infinity. So there's our interval notation, our graph, and our algebraic solution. So that is section 2.6 on absolute value equations and inequalities. We'll see you in class.